In this video, we're going to be looking at a key skill that you need in chemistry, and that is how to identify a redox reaction and then how to write the half equations for this reaction, showing what's being oxidized and what is being reduced. So let's start off by looking at what we mean by a redox reaction. Well, redox is broken down into two parts. It's broken down into oxidation and reduction. And these are two equations and two reactions that must happen at the same time. If you get one substance being oxidized, the other substance has to be reduced. And we'll look at a few examples in just a minute. And when we take these two reactions together, we summarize them using this term redox. Now, we can explain the oxidation or reduction of substances in two different ways. There is oxygen transfer and there is electron transfer. And you are expected to be able to identify both of these and potentially write an ionic half equation to show what is happening. Let's start by looking at oxygen transfer. So when we're looking at oxidation, what we actually mean is that the substance is gaining oxygen. And we say that the substance has therefore been oxidized. The opposite of that would be reduction, and that is the loss of oxygen, and we say that the substance is being reduced. So if we look at an example, if we have magnesium plus copper 2 oxide to give us magnesium oxide and copper, you can see that the magnesium is going from an atom or the element on its own, and it is gaining oxygen to form a compound with oxygen. So we say that the magnesium is undergoing oxidation. Now the copper is doing the opposite. The copper is starting as a compound and it is losing oxygen to become the element or the single atom. So we say that it is undergoing reduction. Now, when something is in a compound, and we're specifically looking at metals here, they are going to be ions, as opposed to when they are the element and they are going to be atoms. And that distinction between atoms and ions is very important when we're trying to write out the half equations, which we will look at in just a few minutes. Now, we can also look at oxidation and reduction in terms of electron transfer. So rather than looking at the loss or gain of oxygen, we can look at the loss or gain of electrons. And oxidation is when a substance loses electrons, and reduction is when a substance gains electron. When the electrons are lost by the oxidized species, so the substance that's undergoing oxidation, they are then gained by the reduced species. This is why we have to have oxidation and reduction happening at the same time. Those electrons cannot just be lost into space. They have to be joined with something else. So when a substance loses electrons, it gives it to the other thing in the reaction and it then gains electrons. And this is what we know as redox reactions. And you can use the mnemonic OIL-RIG to help you memorize that oxidation is loss of electrons and reduction is gain. Now we have to be able to write out a full redox equation or look at the half equations that show us just the oxidation reaction or just the reduction reaction. So we're going to look at an example of how we identify what's being oxidized and reduced, and then how we write this out. So in this reaction, I have got zinc atoms reacting with copper ions to give us zinc ions and copper atoms. Now the first thing that we should do here is we should split it down into two separate equations, each focusing on one of the elements. So I'm going to keep all of my arrows lined up because that makes this nice and easy for you. And I'm going to simply write zinc atoms becoming zinc ions on one line. And then on the line below, I'm going to write copper ions becoming copper atoms. And the way that we can figure out which one is gaining electrons and which one is losing electrons is we can actually look at the number of electrons in each of these species. So we can use the atomic number to help us. Now, zinc has an atomic number of 30, which means when it is an atom, it has 30 electrons. And when it becomes zinc 2 plus, it has lost 2 electrons to become 2 positive. So this species has 28 electrons. Now, the most important thing about the number of electrons is they must balance out on each side. So if I have 30 electrons on the left-hand side and only 28 on the right-hand side, I need to add 2 electrons into my equation. And now I have 28 plus 2 giving me 30. Then we can look at the copper. Now, copper has got an atomic number of 29. So when it has an atom, it has 29 electrons. When it becomes copper 2 plus, it has lost 2 electrons. So on the left-hand side here, I have 27 electrons. Now again, they have to balance out, and that means that on the left-hand side, I need to add 2 electrons. That gives me 2 plus 27 is 29 on the left-hand side, and 29 on the right-hand side. So now I've balanced everything out. I've now figured out that zinc is going to lose 2 electrons to make zinc ions, and copper is going to gain 2 electrons to make copper atoms. So if you remember, we had oil rig. So the oxidation is loss, meaning the zinc is the oxidation reaction, because I've went from having 30 electrons to having 28 electrons. And that must mean that the copper is the reduction, which is the gain, because I went from having 27 electrons to having 29. Now, the general rule when it comes to metals and redox is the following. Oxidation is when we go from an atom to an ion. And reduction is when we go from an ion to an atom. So for an oxidation reaction, we're always going to have the atom to the ion, so your electrons are on the right-hand side of your equation. And when it is a reduction, your electrons are on the left-hand side of the equation. Okay, so we're saying that the oxidation is the zinc and the reduction is the copper. And you can see that that's exactly the correct answer here. So we've got the zinc going to zinc ions plus 2 electrons, and then the copper gaining 2 electrons to become copper atoms. Example 1 is the reaction between magnesium and zinc ions. So we're going to do exactly the same things we just did in the last example. So we're going to write out our 2 arrows, and we're going to just split our equation down into 2 sections. So we're going to have magnesium going to magnesium 2 plus ions, and zinc 2 plus ions going to zinc atoms. And again, we're going to look at their atomic numbers. So if I have magnesium, it has the atomic number of 12. So when it is an atom, I have 12 electrons. When we have magnesium as an ion, it is a 2 plus ion, which means it has lost 2 electrons. So this right-hand side is going to have 10 electrons. Remember, we have to balance these out. So if I have 12 on the left-hand side, to give me 12 on the right-hand side, I need to add 2 electrons. If we look at the zinc, we're going to have the zinc atom having 30 electrons. The zinc ion is a 2 plus, which means it only has 28 electrons. So I need to add 2 electrons to the left-hand side, and that gives me 30 on the left-hand side and 30 on the right-hand side. Now I just need to use my mnemonic of oil rig to tell me what has been lost and what has been gained, and we can see that the magnesium is losing electrons, so the magnesium is our oxidation, and the zinc is gaining electrons, so that is our reduction. If we look at example number 2, again, let's split them down into 2. So we have iron and iron 2, and copper 2, and copper atoms. So let's look at their atomic numbers again. So if we have iron, it has got an atomic number of 26, meaning when it is an atom, it has got 26 electrons. When it becomes an ion, it becomes 2 plus, which means this must have 24 electrons. To balance that out, I need to add 2 electrons to the right-hand side. Now I have 24 plus 2 is 26, and that gives me 26 on the left-hand side as well. For copper, my copper atom has got 29 electrons. My copper ion is a 2 plus, so this becomes 27 electrons. Again, I have to balance it out, and that gives me 2 electrons on the left-hand side. And using oil rig, oxidation is loss, so the iron is losing electrons, so it is the oxidation, and the copper is gaining electrons, therefore it is the reduction reaction. One more example using this same type of methods, and then we'll look at one that's a little bit more challenging. So we have zinc and silver. So I have zinc atoms becoming zinc ions, and then silver ions becoming silver atoms. So zinc has the atomic number of 30, which means as an atom it has 30 electrons. When this becomes an ion, it becomes zinc 2 plus. That means I have 28 electrons. So to balance this out, I need to add 2 electrons to the right-hand side of the equation. When silver is an atom, it has 47 electrons. Now this one's a little bit different when it becomes an ion because it becomes a 1 plus. So this time we go to 46 electrons. So I only need to lose 1 electron here. So I've got 1 electron being added to the left-hand side to give me 1 plus 46, which equals 47. Now, what we know about reduction and oxidation reactions is we cannot lose out any electrons. So if we use our mnemonic oil rig, we know that the zinc is being oxidized because it is losing 2 electrons, and the silver is being reduced because it is gaining electrons. But what we have to do is we have to balance it out. If the zinc loses 2 electrons, what we actually need is 2 silver ions gaining 1 electron each to give us 2 overall to make 2 silver atoms. Now, sometimes what they will do is they could give you a redox reaction where it's looking at the oxygen transfer. So all the ones that we've been looking at are electron transfer, but for oxygen transfer, we can identify what's being oxidized and what's being reduced, but we can actually still write out a half equation using the electrons. So if we've got magnesium going to magnesium oxide, what we need to realize is that this is an atom and this is an ion, whereas for copper, it's going from the ion to the atom. So again, we're going to split it down into our two sections. So the magnesium is nice and easy because it's just magnesium solid. But then when it becomes into magnesium oxide, we need to figure out what is the ion that is in magnesium oxide. And that's when we look at our ionic formula. And magnesium oxide is actually written out as Mg2 plus O2 minus. So this is becoming a magnesium 2 plus ion. Okay, and we already know that the magnesium is going to be oxidized because it's gaining oxygen. But let's write out the half equation so that we can just prove that. So then we have copper. When we have CuO, its ionic formula is Cu2 plus O2 minus. So this is going from copper to ions to copper solid, or copper atoms. So then we're going to look at what's being lost and what's being gained. So magnesium has an atomic number of 12. When it becomes a magnesium 2 plus, it has lost 2 electrons. So this becomes 10. So I need to add 2 electrons to the right-hand side. When I look at copper, I've got 29 electrons when it is an atom. When it becomes an ion, it becomes 2 plus. So then the left-hand side only has 27 electrons. So I need to add in 2 more in order to balance it. Therefore, for oil rig, the oxidation is the magnesium and the reduction is the copper. And we can also look at that in the same way that the magnesium is gaining oxygen, so it is becoming oxidized, whereas the copper is losing oxygen. So it is the one that is being reduced. Then we're going to do one more example just to finish off, where we've got zinc reacting with cobalt oxide, and that gives us zinc oxide and cobalt. So we can see again that this is the gain of oxygen and this is the loss of oxygen. So we know that the zinc is going to be oxidized and the cobalt is going to be reduced. Now, we want to write out the half equations for that, so then we need to figure out what's the atom, what is the ion. Well, when it's zinc solid, that is the atom, whereas cobalt, when it is bonded to oxygen, is in the form of an ion. Zinc oxide contains a zinc ion, whereas cobalt metal contains the atom. So let's split it down into our two sections again. So we have zinc going to zinc ions, and let's just look at our ionic formula. This should be Zn2 plus O2 minus. So this is going to make zinc ions. When we have cobalt oxide, that is cobalt 2 plus, oxygen 2 minus. So that tells us that this is a cobalt ion forming cobalt metal. And we can still look at the atomic numbers to help us. So zinc, when it is an atom, contains 30 electrons. When it becomes an ion, it has lost 2 electrons to become 2 positive. So that is 28. So I need to add in 2 electrons to the right-hand side. When we have cobalt as an atom, it has an atomic number of 27. So it contains 27 electrons. when it becomes an ion, it becomes 2 plus, and this has got 25 electrons. So I need to add in 2 electrons to the left-hand side. Again, using the mnemonic oil rig, I know and can confirm now that the oxygen is being oxidized because not only is it gaining oxygen, it is losing electrons. And the reduction is the cobalt because it is gaining electrons and it is also losing oxygen. So that's how we write out the half equations from a redox reaction. So you always want to split it down and to focus on one single element, figure out the number of electrons on each side, and then add a certain number of electrons in order to balance that out. So add 1 electron to one side, or 2 electrons, or 3, or however many are required. You might want to keep practicing this, and there are some examples in the double science textbook, or certainly ask your teacher for some examples if you want to practice it a bit more. I hope this has made sense, but if you do have any questions, please feel free to leave a comment below, and we hope to see you back on the channel soon.